So today we are going to be solving some AS level chemistry difficult questions from the chapter of equilibria. So let's get started. The first question says it was tested in May June 2020. It's a tricky one. Which solution has the lowest pH value? Okay, so pH value, you know what it tells? It tells your hydrogen ion concentration. Basically, pH value, the lower the pH value, the more H plus ions you have in a solution. So we're looking for a solution that has the lowest pH value. That means we're looking for a solution that has the highest H plus ion concentration. So we need the highest H plus ion concentration. Now the thing over here that we need to keep in mind that butanoic acid, ethanoic acid, they're organic acids, and organic acids always have a lower pH because they are weak acids. Why they are weak? Because organic acids do not dissociate fully in aqueous solutions. So either it's going to be HCl or sulfuric acid. Firstly, we know these two are organic acids, so let's cut butanoic and ethanoic acid. Okay, now we have our HCl and sulfuric acid. If you write down the formula for HCl, it is HCl, and for sulfuric acid, it is H2SO4. We need to figure out which acid is gonna donate more H plus ions. It's simple. We can see this is a protoic acid, I guess we call it. Why? Because it gives two protons. Hydrogen ion is called a proton. A simple H plus ion is going to be called a proton. So this acid, when it's going to dissociate, what's going to happen? The dissociation equation for sulfuric acid, it's going to be H2SO4 gives you 2H plus SO4 negative, and for HCl it's going to be that a single HCl is going to give you 1 H plus and 1 Cl negative. So over here there's a fair comparison which you can see that sulfuric acid gives you 2 H plus, whereas HCl it gives you 1 H plus ion. So obviously sulfuric acid is going to give you more H plus ions, hence it's going to have the lowest pH. The next question says that ammonium carbonate, okay, let's write down the formula first for ammonium NH4 and then for carbonate CO3. Since carbonate it has a 2 negative on it and ammonium is a +1, so we're gonna require 2 ammoniums to balance it out. Is a crystalline solid. Okay, on gentle warming a reaction occurs forming ammonia as one of the products. How are carbonate ions behaving during this reaction? Okay, look over here. Now what's happening is that you have your ammonium carbonate and you're heating it. So you are providing heat to it and you form ammonia as one of the products, and other products, they are not listed. Okay, we don't know how many products and what not. Okay, so what's happening over here is Bronsted-Lowry acid, Bronsted-Lowry base, oxidizing agent or reducing agent, carbonate ions. Ammonium is going into ammonia. Okay, ammonium is going into ammonia. Ammonium has H4 and ammonia has H3. That shows us that ammonium loses a proton to form ammonia. That's simple. A proton is a hydrogen ion, you know. So ammonium, that's simple. We can write it down to make things clear that what's happening is that NH4 plus loses a proton, which is also called a hydrogen ion, to form ammonia. That means that this thing NH4 is losing a proton. ठीक है, देखें अब यहाँ पे it's going from 4 to 3, and when something loses a proton you simply call it an base. Why a base? Base are proton acceptors. Acids are proton donors. It's losing a proton. Is it a base or an acid? An acid. I was just testing you guys. Will you fall in this trap? And you all fell, I guess. It's gonna be an acid. Acids are proton donors. It donated a proton. So if this acts as an acid, what's gonna be carbonate? Obviously it's gonna act as a base, because if this is acid, this has to be a base. This has to accept the proton donated by this ammonia. So it's gonna be a Bronsted-Lowry base. Why? Because ammonium is an acid. ठीक है, it's donating a proton, and when something donates a proton, something has to accept it. There's only one other thing, which is a carbonate. So carbonate is going to accept that proton, and we don't know the products that are going to form. Okay? But still, we know that the whatever products may form, they're going to have a proton that's donated by this ammonium ion. I hope you get it. Next question, it's about some equilibrium thing. Okay, PCl5 decomposes as shown. This is PCl5. It's forming phosphorus 3 chloride and chlorine. 1 mole of PCl5, 1 mole of PCl3, and 1 mole of Cl2 are placed in a container volume 1 dm cube and allowed to reach equilibrium. At this temperature, the equilibrium mixture contains 1.8 moles of PCl3. What is the value of Kc? That's a very simple question. You just write the equation, which is PCl5 forming PCl3 plus Cl2. You have 1 mole of this, 1 mole of this, and 1 mole of this. Okay, you have 1 mole of each of them. Okay, initially you have 1 mole. Now the change in mole we don't know right now, and the equilibrium moles, meaning the moles that are going to be present at the equilibrium, there are 1.8 moles of PCl3. Okay, in blue I've written everything that was given in the question. Now from this we can figure out that the change in moles for PCl3, the change in moles is 0.8, because initially it was 1, and now they're 1.8. That means 0.8 moles are being formed. So 0.8 moles of PCl3 formed. If 0.8 moles of PCl3 formed, that means it's 1:1:1. That means 0.8 moles of Cl2 as well formed. They're going to be 1.8 moles of Cl2 as well, because you add this and this. And if 0.8 moles of PCl3 are formed, then since it's 1:1, 0.8 moles of PCl5 are going to be utilized. Okay? I hope you get it. So it's going to be 0.8 moles of this are going to be utilized. So there's going to be a negative sign. So 0.2 moles of this are going to be left at the equilibrium. 1 minus 0.8. Now we write the Kc expression for this. What's going to be the Kc expression? It's going to be simple. Kc value is going to be equal to the PCl5 moles. No, it has to be PCl3 moles. Then it has to be Cl2 moles. And in the denominator, it has to be PCl5. Because the products, they're at the top, the reactants are at the bottom. And since there are no 2 or 3 moles, there are not going to be any powers involved. There's only going to be the power of 1. So now let's plug in the values. For PCl3, it's going to be, for PCl3, it's going to be 1.8. So let's write 1.8 upon 0.2. Do it on your calculators. Let's see what we get. 1.8 times 1.8 upon 0.2, and we get 16.2 as an answer, which is option number D. I hope you get it. Moving on to this question, which says that a catalyzed formation of ammonia, okay, we are using the catalyst. Which catalyst we use in the Haber's process? Iron catalyst. Okay, in the Haber's process can be represented by the equation. You have nitrogen, you have 3 moles of hydrogen, you're forming ammonia, and it's happening at -2 degree. It's releasing -2 kilojoules per mole, which tells us this is an exothermic reaction. Which change in conditions will increase both the rate of formation and the equilibrium yield of ammonia? Okay, so firstly, rate increases. We are not talking about yield right now, we're just talking about rate. Rate increases if you increase the pressure or if you increase the temperature, or if you add catalyst. These 3 things are gonna increase your rate. So decrease in temperature, no. Increase in surface area of the catalyst, no. Either it's going to be increase in temperature or increase in pressure. Now we have to check these both will increase the rate. Now we have to check, will increase in temperature move the equilibrium yield towards the right, because we need more of the ammonia. So if we increase the temperature, what's going to happen? Ab dekho, what Lee Chatterley's principle states that whatever we do to the equilibrium tries to reverse it. It tries to undo it. So if we increase the temperature of the equilibrium will try to reduce it. The forward reaction, this reaction, this is exo, and the backward reaction is endo. So if we increase the temperature, the equilibrium will try to decrease it, and to decrease it, it's going to move backward. So it's going to be endothermic. So when it moves, why it's going to move backward? Because it has to decrease it. Whatever we do, it has to reverse it. So it's going to move backwards, and then the endo part is going to happen. So increasing temperature is basically decreasing ammonia, because it's making the reaction move backwards. We need the reaction to go forwards. Obviously not option B. Increase in pressure. Now let's check. Increase in pressure. Pressure has to do with moles. So in total 1 mole and 3 mole. In total we have 4 moles on this side and 2 moles on this side. 2 moles. When we increase the pressure, it moves the equilibrium towards the side that is less moles. Okay? So just write it over here if you don't remember it, that when you increase pressure, equilibrium moves towards the side that has less moles. And when you decrease the pressure, equilibrium moves towards the side that has more moles. So now, since we're increasing the pressure, equilibrium is going to move towards the side that has less moles. Which side is less moles? This or this? Obviously the ammonia side, so it's going to move forward. So it's going to be option number C, increase in pressure. Okay, carbon monoxide burns readily in oxygen to form carbon dioxide. What does this information suggest? Okay, carbon monoxide, which is CO, burns readily to form carbon dioxide, which is CO2. The +4 oxidation state of carbon is more stable than the +2 state. Dekho. No. +4 means you have lost 4. Okay? And +2 means you have lost 2. How many? It's going to be a yes, because carbon has 4 electrons in its outermost shell. Okay? But this information, carbon monoxide and carbon dioxide information, does not suggest it, because in carbon monoxide the oxidation of carbon is, dekho, it's gonna be a +2, and over here it's gonna be a +4. Why a +4? Because oxygen is -2 and you have 2 oxygens, so -2 times 2, it's gonna be a -4. To balance out a -4, you need a +4. Okay? So you have a +2 on carbon monoxide and a +4 in carbon dioxide. And it burns readily. It means it's happening in favor. So if it burns readily, that means that it's a favorable thing that's happening. That it's going from +2 to +4. And why is it favorable? Because +4 is going to be more stable. Why? Because if you look at carbon, this is carbon. This is the last shell of carbon. The last shell of carbon, the first shell, it's gonna have, the first shell has 2 electrons, and the last shell, it has 1, 2, 3, 4 electrons. Okay? Now what's gonna happen? And there are 2 in the inner shell. Carbon needs stability. Every atom needs stability. And it can gain stability either by gaining 4 or losing 4. Losing 2, if you lose 2, if you make it lose this and this, it's not going to be stable with +2. If it's +4 and it loses 4, now it's stable. It has 2 electrons in its inner shell. So it's going to be stable with a +4 oxidation state. So it's going to be option number 1. The standard enthalpy change of formation of carbon dioxide is more negative than the standard enthalpy change of formation of carbon monoxide. Okay, so for carbon monoxide, you need to form a carbon oxygen triple bond, out of which the last bond is a dative bond. And for carbon dioxide, you need to form two carbon oxygen double bonds. So the enthalpy change of formation for carbon dioxide is more negative. Yes, you're forming more bonds, so it should be technically more negative. And with this, you're given a data booklet which has all the enthalpy changes from which you can see it. But right now I'm not using it, I'm just guessing that it's gonna be more negative, but you should use it because you guys have to give like the exam thing. Okay, the value of equilibrium constant for reaction 2CO plus O2 is likely to be high. It's likely to be high. You know why it's going to be likely to be high? Because the equilibrium is going to be towards the reactants, towards the product side. And you know why equilibrium is going to be towards the product side? Why? Because this state of carbon, the carbon dioxide carbon, it's going to be more stable because it has a +4 oxidation state. I just told you right now that a +4 oxidation state is going to be more stable at any cost than a +2 oxidation state, because +4 means carbon has a full outer electron shell. The 4 electrons from the outer electron shell removed, the inner shell it only has 2, so it's stable. So when you form more product, when your equilibrium lies towards the product, basically then your Kc value or Kp value is higher, because Kp value is directly proportional to the product and inversely proportional to the reactants. So it's gonna be 3 is also gonna be correct. So it's gonna be option number A, which says 1, 2 and 3. Moving on, what are the units of Kp for this reaction shown? Okay, so it's gonna be no units. Why it's gonna be no units? You might think it's gonna be no units, but it's not gonna be no units. You know why? Because we don't include solids in the Kp expression. So Kp expression is gonna be carbon monoxide concentration, then hydrogen concentration upon H2O concentration with no carbon concentration. We are not going to include this concentration. Why are we not going to include this? Because it's a solid, and solids don't have concentrations. Simple. So this cancels with this, so it's simply gonna be A Pascal, which makes option number B correct. Okay. Ethene can be oxidized to form epoxyethene. Ethene can be oxidized to form epoxyethane. Forward reaction is exothermic. Which set of conditions give the greatest shield of epoxyethane at equilibrium? Pressure. 2 moles on this side, 1 mole on this side. You need more of this. I just told you right now that when you increase the pressure, it moves the equilibrium towards the side with less moles. This side has less moles. So if we want the equilibrium to move towards this side, what do? We need to increase the pressure. So we need a high pressure. And since it's an exothermic reaction, the forward reaction is exo, the backward reaction is endo, and we want the reaction to move forward. Okay? So what are we gonna do? We want the exo part to happen. I want heat to be released, so I need to decrease the temperature. When I decrease the temperature, the reaction mixture will try to increase it, and when it will try to increase it, it's gonna release heat, so it's gonna be a lower temperature. So making option A the correct one. Which statements are correct? Okay, this is periodicity related. So moving on to question number 15, which says solid ammonium nitrate is put into a test tube and solution X is added to it. Okay, you have ammonium nitrate, which is NH4NO3, put into a test tube and solid X is added to it. You add a solid X, the resulting mixture is warmed and the gas given off is tested with damp red litmus paper. The litmus paper changes color from red to blue. What could be the identity and its role in the reaction? Okay, firstly, you're producing ammonia gas. Okay, so basically, this. What is this? This is an ammonium. This is an ammonium salt. Okay, and this is ammonia gas. Whenever you're gonna add an alkali to an ammonium salt, you produce ammonia gas. This is a very famous reaction, that ammonium salt plus alkali gives you ammonia gas. Ammonium salt plus alkali gonna give ammonia gas. So identity of X is gonna be a alkali. Role of X, either it's gonna be a proton donor or proton acceptor. What's happening to ammonia? Look, what's happening to ammonia? It's losing a proton. So ammonium is losing a proton. So ammonium is a acid. So this NaOH is gonna be an alkali. It's gonna accept a proton, because if this is losing a proton, then this has to accept it. So it's gonna be a proton acceptor. And with that, we end today's video.